Hello, everybody. Welcome to the December 2025 SJAA imaging meeting. And tonight we have Jared Willson, who's going to talk to us about NINA. So take it away, Jared, please.
Thank you. Hi. I've split this presentation into two pieces. So one is just a little bit of background on NINA, where it came from, what it's intended for, what its competition is. That will be a slideshow. That'll be brief, only about 15 slides or so total. And then we'll actually dive into NINA and use it. I have a telescope at a remote observatory in New Mexico, and we'll use it to run the telescope. The weather there is good, so we can see results in real time, and I'll walk through the steps for configuring and getting it going, and we should be able to test it out. So just brief background on me. I'm a member of the East Bay Astronomical Society. Been doing astrophotography for a lot longer than I'd care to admit, but long enough to where I remember guide scopes with illuminated reticles and film cameras. Um, and you can find me most weekends volunteering as one of the docents at Chabot Space and Science Center in Oakland. So in terms of agenda for tonight, I promised the slideshow will be brief, but a little bit of history on NINA that will add some context in terms of what it's good at, what it isn't good at, et cetera, why it's organized the way it is. And then we'll dive into the software itself. I'll go through the user interface, how to get it set up and running, try to highlight some of the more important plugins and give you an idea of some other options that are out there, because there are a lot of third-party apps now for NINA, little plugins that you may find useful. Then we'll dive into the user interface specifically on the imaging tab. It's by far the busiest tab in the application. And I like to simplify it a lot, so we'll go through how does that work. Cover one really cool little tool in NINA, which is the flat wizard for auto-generating your flat library for a given imaging run. And then go through the tools, the Sky Atlas for finding targets you might want to observe, the framing tools for actually choosing the exact framing for your particular camera and telescope. And then 90% of NINA is the sequencer. So we'll spend the most time on how do you build sequences, how do you utilize them, what about if you wanted to image multiple targets in a given night, how do you do that, things like that. And then finally, we'll finish up with how do you get support on NINA if you have problems. With that, really brief history of NINA. So back in roughly 2010, there really wasn't anything like NINA. You typically had software designed for your specific little pieces of hardware. You might be using Maxim for cameras and filter wheels. You'd probably have some planetarium software. If you had some budget, you might be running the Sky. You'd be running something else for focusing your camera. Mount control was 90% of the time was just through a keypad that was physically attached to the mount. PhD was out for guiding, but it wasn't PhD 2 yet. I think it was still the original push here dummy for guiding. And there really wasn't anything for scheduling out your observing runs. Most astronomers weren't doing plate solving yet. There were no rotators yet. Flat panels weren't in common use. They existed, but they weren't as evenly illuminated as one might like. Weren't available in all the sizes we might need, etc. So remote imaging was really in its infancy. The big player on the block was DC3 Dreams. They had a product called ACP. So if you had spent a bunch of money building your own observatory, or were in one of the relatively uncommon remote shared facilities at the time, you were probably running ACP, and it was pricey. But it had a lot of cool little tools like Pinpoint for building out precision pointing models so that you could actually get your telescope pointed at what you wanted, even when you weren't physically there to fix things. It used mostly Maxim and scripting tools for getting imaging running. It wasn't exactly elegant, but it did work, and there wasn't a huge number of astrophotographers out there who needed um, a complete software package. Then somewhere around 2010, you had the Sky X Professional got released. The Sky X Professional from Software Bisque was the first application I'm aware of anyway that had was intended to control everything you might need. It would run your dome if you had a home dome. It would keep the slit oriented with respect to your optical tube. It would run your mount, it would run your telescope, your filter wheel, everything you needed. And it included image sequencing. So it was intended to be an end-to-end solution, but there were a couple little problems. One was it was really focused on software BISC mounts in particular. You weren't totally out of luck if you were running something other than a software BISC mount, but it was clearly oriented towards them, and a lot of the more advanced tools were only compatible with software BISC mounts. And the Sky decided they wanted to run everything native. So even though ASCOM was out for platform support for accessories, they didn't want to use it. And they also didn't want to develop drivers for every little accessory. So there were a lot of things that just didn't run in the Sky X. Then somewhere around 2014, version 2 of Sequence Generator Pro was released. That was the first Nina equivalent, I'll say, that was really aimed at giving you full hardware control, let you develop fairly, actually very complex image sequences. It wasn't nearly as expensive as ACP on DC3. It was still not cheap, I think in the neighborhood of $1,500 or so, but it was bearable for someone who was trying to do remote imaging, whether that was from home observatory or something further away. So what changed that resulted in Nina? Nina was released in 2019. It was the first application of its type that was open source, free to use. It had native support of a fair number of cameras, didn't need ASCOM, which was good. They would leverage the SDKs from the camera manufacturers. That was important because I tried hooking up in an early version of Nina. I tried hooking up one of my cameras via ASCOM at first, and not realizing I needed to use the native driver, and the download speed was like a minute and a half per frame instead of 2 or 3 seconds per frame. So there are a few things where you really do want native drivers, and cameras are one of them. And so that's what they did. They adopted the SDKs from the camera companies so you could run your camera natively. But they didn't cut out ASCOM. So if you want to connect to your focuser, to your filter wheel, to your weather monitoring system, et cetera, all of that was done via ASCOM. So they didn't have to write drivers for any of that, which was great.
Hey, can I just mention that it isn't the only open source free, and nor was it the first open source free.
Oh, what else was
K-stars,
free that covered the same thing?
K-stars. It's just maybe
Uh,
it was, but
yeah, so
a lot of people forget about it because it's not Windows. But
no, I do mention K-Stars a little later, but I thought K-Stars was later, so my mistake if I got the order wrong.
so no problem.
Uh,
But thank you.
and there were a couple of applications that Nina didn't try to handle or compete with. Two in particular, plate solving. Aztec.
I don't hear Jared. Can somebody unmute and say if it's just me?
Yeah, no, we lost him.
Okay. Let's give Jared a chance to come back. Sorry about that interruption. Okay, you back, Jared?
I didn't realize I'd left.
Yeah, sorry, you left not long after my comment, so
no worries.
Continue from there.
Sure. So there are a couple places where Nina didn't try to cover what was already well traveled. So PhD2 for guiding. was already almost universally adopted and very capable. They didn't try to replace that. They just integrated with it. There's several different plate solving solutions where they leverage what was already out there. ASTAP in particular is very popular within Nina because it's quick and reliable. There are a bunch of Sky Atlases they integrate with. They didn't try to build their own. So really the key things were the free/open source, the fact that they supported third-party plugins, and they adopted ASCOM. So that made it very popular. Okay, then in 2022, Nina finally became competitive with SGP in Sequence Generator Pro in terms of its core capabilities. So in particular, the advanced sequencer was released. And it came at very much the right time for Nina. You had hosting costs coming down dramatically, people beginning to ship off telescopes to this growing farm of telescope farm system for getting decent skies. The number of plugins started increasing so that Nina was appropriate for a wider group of astrophotographers, and it quickly came to dominate the amateur market. So are there any reasons that you would want to use anything else for image capture? There's still some niche areas where I think Nina may not be the best choice. First of all, it isn't really an end-to-end solution. It covers image capture, but it does not cover image processing at all. There are a couple of integration touch points to PixInsight and a couple of other applications that can do the basics of data reduction or calibration. It'll do some live stacking now with a plugin, but that just isn't its strength, right? So it's really intended for image capture for later processing. So traditional deep sky astrophotography. If what you're interested in is simplicity, you want to run something on your iPhone or your iPad, you're probably better off with something like an ASI Air, or there's some competing products now to the ASI Air as well. Or if you're running a smart telescope, it'll have its own software. So it's really not aimed at the, hey, I just want to plunk down this smart telescope, create a pretty image that I can share with my friends, and after a couple hours, I'm done. That's not what it's for. It's really for dedicated deep sky imaging rigs. It does now have live stacking technique. Oh, it does technically, by the way, have a plugin if you want to run it on your iPhone now. I've played around with it. I don't think it's there yet, but it exists. You can have fun with it if you want. It's called, what is it called? Touch and Stars. So that's their little iPhone app. It does have a live stacking capability as well now, but I much prefer SharpCap if that's what I'm doing. So for things like electronically assisted astronomy or outreach events, things like that, I'd still stick with SharpCap or something equivalent. And Nina's really Windows only, and they have no intention of changing that at this point. So if you want to run Raspberry Pis or want to run Linux, it's K-Stars and Ecos.
Or Mac, by the way.
Or Mac for, yes, true. Not for Nina, just for K-Stars and Ecos.
Right.
Yep. Okay, so what are the prerequisites if you want to get up and running on Nina? So you're almost certainly going to want PhD 2, unless you have a high-end mount with absolute encoders and you don't plan on guiding. You will need the ASCOM platform installed so that you can reach your guide camera, focusers, flat panel displays, whatever accessories you have for your system. Do make sure your native camera driver is already installed because Nina's going to want to leverage it. ASTAP, I think, is not quite universally the plate solver of choice, but pretty close. So you'd want to make sure that ASTAP is installed and that you've downloaded the data sets. There's one plugin in Nina that I consider an absolute must, and that's Hocus Focus. Nina does have its own software focusing routine, but the plugin, Hocus Focus plugin, is vastly better. And I've got a link here to a YouTube video from the developer of Hocus Focus on how to configure it to give you better results than you will get out of Nina natively. Highly recommend you watch that if you install Hocus Focus and give it a try. It'll help you address issues like, well, what about telescopes that have large secondary mirrors that maybe don't perform quite like an optimal telescope? How do I make sure it's choosing the right stars to measure half flux radii? What do I do about a telescope that hasn't fully equilibrated, so it's giving different results on either side of focus? Hocus Focus can take care of all of those things and get you really good, accurate focus points where Nina's native focusing routine is not quite there. And then finally, there are some mounts that have advanced pointing models in them. Astrophysics mounts, ASA, 10 micron. So a lot of the higher end mounts with absolute encoders or just with very high accuracy have plugins for building pointing models in Nina that can simplify the process a lot. So if you have one of those mounts, definitely look for a plugin. Don't just run the mount without. That's kind of it in terms of prereqs. So I think that's all I wanted to go through before we dive into the software itself. So any questions on history or background before I move into the app? Okay, I will switch over to the application then.
So tell us also a little bit about where we're going.
Yeah, so we are going to, let me get it up and running and then I will tell you. Where did I put it? Hold on. Oh, I don't have it turned on. So we're going to be we're going to be using remote desktop AnyDesk specifically to get into my telescope that's hosted at Deep Sky West in Rao, New Mexico. The weather there is good tonight, so we'll actually be able to run the system, which is great. And it's a 12-inch, relatively fast f3.8 reflector. And let me share the screen now. There we go. So you all should see pretty much an empty desktop from a Windows machine at the observatory in New Mexico. The only things I have running on it at the moment, I've got some VPN software running so that I can do file transfer to my local server here at home. Yeah.
Can you just put on your first slide and show folks?
Yeah, absolutely. I'll show you the
literally where we're going, right?
Yeah, let me switch back to that 1 second.
Because I thought that was a great slide.
Sure, let me just bring it back up. That was this one. And let me share that. There we go. So this here is the observatory that we're about to remote desktop into. This telescope that looks like it's covered in aluminum foil is my telescope there. This is part of Deep Sky West, which is one of the older remote observatories out there. They have two roll-off roof observatories. This is the one for the little telescopes. So anything up to about 14 inches goes here. And the roll-off roof observatory that you can just see the edge of on the right side here is for the big boys. Anything up to about, I think the largest one they have in there is a 24-inch. So that is where we're headed. Let me stop sharing and go back to just sharing the remote desktop so that it fills your screen better. 1 second. There we go. All right. So this is a very low-powered Windows machine, 128 gig of storage. I don't know what the CPU is, but it's terrible. But it's enough to run the hardware. You don't push the hardware very hard with things like Nina and just the basic telescope hardware. So the things it's running at the moment, I showed you the VPN software. This is an astrophysics mount. So Astrophysics Command Center Pro is used to control the mount. Nina integrates with it nicely. I have PhD2 already up and running and connected. So it's connected to my camera, an ASI guide camera, and the mount. So that's good. And I think that's all. Yeah, that's all that's running at the moment. This is the ASCOM driver for the mount. So nothing else is running. So we will launch Nina from here. And I have reset the user interface in Nina to factory defaults. So we will go through the complete process of getting it configured for your use. It's slow to launch on this computer just because it's an agonizingly slow computer, but it does the job. So we'll give it a couple seconds to come up. There we go. So the first thing to notice in Nina, your major navigation is along the left-hand edge here. So you have little icons here for controlling the equipment, getting to the Sky Atlas, framing, running the flat wizard, etc. The heart of it is going to be the sequencer. We'll get to that in a moment. Imaging, where you actually monitor what the heck is going on. Options is where we'll do a lot of the configuration, and then the plugins. So we're going to start. Well, actually, one more thing. So a couple of these tabs, the equipment tab, the options tab, and the plugins tab all have a second set of icons behind them that are just to the right of the first set. So when we're in the equipment tab, which is where we are right now, you can see you've got an icon for getting the camera connected and configured, the filter wheel connected and configured, focuser, etc. So all the different pieces of hardware. You can't change the list that's here. It's permanent. If you don't have some of those pieces of hardware, no worries. You don't need to do anything about it, but the list is preset and it is what it is. The other two tabs that have a similar structure, if you click on options, you've got general setup, equipment setup, getting your autofocus working, dome control if you were running a dome, imaging and plate solving. And then plugins also has little tabs behind it. So what's installed and what's available. So two sections only for the plugins. For some of the pages, just again, getting to general navigation, like if I click on the imaging tab, this is the one that I think is way too busy with the default settings. But a lot of these, and we're going to simplify it in a couple minutes, a lot of these pages have icons across the top as well for turning on and off various features. So we'll be going through those. But things like if you hover over them, it'll explain what they're for. Like, how do I set up the star detection options for Hocus Focus? How do I make sure that, or how do I make sure I can see or find a manual focus target, a bright star for me to choose and salute to? How's it going to annotate stars? Will it have a little tab for autofocus, etc.? So you get a ton of little icons up here. So if you're ever missing something on one of these displays, odds are pretty good it's somewhere across the top here. Okay. First thing I wanted to cover in terms of configuration is color schemes. In options, in general, which is where we're starting, you can choose different color schemes for Nina. This is kind of convenient if you might be running it in the field. Maybe you want to turn on a nice red color scheme that won't disturb other viewers. So dark nebula, for example, will darken the screen a fair amount. There was a actual red one in here. Where is it? Oh, dark. The one that's just labeled dark is really dark, and what is lit up tends to be red. I'm going to put it back on the default one, which is called light. I've got it labeled custom because there's one thing I changed on it, but it's really, this is the light color scheme. This will work well if you're running Nina from your living room or den and controlling a telescope in the backyard. You're not worried about blinding yourself. Light is nice and legible. So the ability to change color schemes, kind of nice. Not a huge deal, but it's nice. But aside from just getting the color scheme set up, there's a lot you need to do to get Nina going the first time. So first thing to be aware of, you can store multiple profiles. Maybe you have maybe you have 2 or 3 telescopes that you run in Nina. You'd want a separate profile for each so that it knows, oh, this is the camera associated with this profile. This is the focal length of the telescope. Maybe you have a couple common observing locations. You'd want to store a separate profile for each observing location. In my case, I'm using Nina to run one telescope from one location. So I've got just this one profile here that's called Honders, because that's the type of telescope that I'm running. And then I've got a copy of it in case I ever mess up the profile and want to recover. I can go back to the backup copy of it. So you're going to start with just one called default, but you can make copies of it by adding plus, making changes, and toggle back and forth between them whenever you want. So if I wanted to switch to my backup profile, I would just click on it, hit load profile. It'll end up looking the exact same because I've only got the one telescope, but you can have as many in here as you want. And there are times when you actually need them. So we'll get to that. All right. Advanced settings, there are 1 or 2 things in here that you'd care about. Probably the most important one is actually just the auto update source. Where is it going to look for updates? Do you want to be running the stable release? Do you want to be running the latest beta software? Or do you want the nightly builds? This used to be a bigger deal with Nina when they were introducing a lot of new features very frequently. You might well want the nightly builds now. I tend to just run it on, whatever is the current actual stable release. And I haven't noticed major gaps in terms of functionality. And then the other thing that I'll point out here is the hardware acceleration tab. And by the way, there are tooltips here. So if you hover over things, it will give you a brief description of what things are for. So if you're having trouble with screens blanking out, or I've had this happen a couple times back with some older hardware, it wouldn't show the image that I had just finished taking. I had to turn off hardware acceleration, and then everything worked fine. So it's good to know that it's there. And then astrometry down here is where you put in the specifics of your site where you're observing from. So latitude and longitude, elevation as well. So the Deep Sky West is on top of a mesa, so it's at 2,200 meters, which is, 6,000 some odd feet, 6,500 feet, something like that. And it's got a little map. It'll show you where it's located. That's where it's about 45 minutes southeast of Santa Fe. And that's pretty much everything you need on this general tab. Okay, and it's best when you're first configuring Nina. I just walk through each of these and fill them in as best you can. So general, now we'll jump to equipment. So camera, for it to fill in the appropriate information into your FITS header for your images, you want to tell it your pixel size, bit depth, bear pattern. I've always left it. I'm running a monochrome camera. I just leave it on auto. If you happen to know your bear pattern, if you're running a one-shot color camera, you can actually stick it in, but auto seems to work pretty well. I know PixInsight in particular will do a really good job of diagnosing what your bear pattern is, so you shouldn't have to specify it. Focal length of the telescope is important. Focal ratio is important. this is all information that's just going to get into the FITS header, which will help with plate solves and things like that. This is what I found with my particular mount after it's run a slew. How long does it need before it's fully stabilized? And I don't need to worry about, oh, my stars will be a little bloated in right ascension or something. If I give it 5 seconds to settle down, it'll be in good shape. It works pretty well even with 2 or 3 seconds, but I'm fairly conservative, so I put it at 5. So location, so coordinate sync and time sync. This is if you have a mismatch between whatever location is in your mount and what's on the computer, or whatever time is in your mount and what's on your computer. Is it going to try and sync them up? And you want it to prompt you as when it's going to do that. Next, I'm going to jump over to the filter wheel on the right-hand side of the screen here. I have a 7-position filter wheel. You get to name your filters. This is surprisingly important because a lot of things in the advanced sequencing are dependent on the filter names. So you want to settle on a set of filter names and don't change them. If I were to decide, gee, I really want this to be an L filter instead of a luminance filter, that would mess up a lot of the other configurations I've done. So you want to set this once at the beginning and then leave it alone, assuming your filters actually are stable, right? That you didn't add a bunch or take some out or something. This one filter, my filter number 7, is a little unusual. Since it's a remote telescope and it's fairly large, I don't have a way to put a lens cap on it. So the last slot in my filter wheel, I don't have a sulfur filter. So instead, I just put a blanking panel in there. That'll let me take darks even in broad daylight, which is really nice. It also keeps dust off the cover slip or cover glass over the sensor chamber. So if you see that dark slot there, that literally is a blank piece of plastic that blocks any light from getting into the camera, since I don't have a lens cap. I think everything else I've got in here is default. I didn't change anything in it. There is a weather station at Deep Sky West, but I have that integrated into the astrophysics software, so I don't need to put it into, I don't need to query any of the APIs that are available for trying to get weather information or approximate weather information. This would be, when would you even care about this? You might care if, well, for example, I'm running an advanced pointing model. It corrects for atmospheric refraction. For it to correct for atmospheric refraction, it's got to know the temperature and pressure. So there are times when you would want this sort of thing, in which case you can go to Open Weather, get an API key, put it in there, and it'll query down the weather information for your location. These are the default ports and so on for ASCOM. Nothing I needed to configure there. Yeah, I think the rest I left alone. Autofocus. Couple key things in here. The first is down at the bottom, which is my telescope does not, even though the filters are supposed to be have the exact same focus, the telescope doesn't. The filters may well be the same thickness, but my point of perfect focus for luminance and my point of perfect focus for red are slightly different. Luminance matches green, blue is off a little bit. So for red, I actually want to be focused slightly in compared to my luminance frames. Blue, I want to be focused slightly out. My 2 narrowband filters are completely different from my RGB filters. You can put into Nina autofocus filter offsets. And then you don't need to focus every time you change filters. It just knows, oh, I switched from the luminance frame to the red filter, I need to move in 30 microns. Or I switched to the blue frame, I need to move out 25 microns. It'll handle all of that automatically. It's kind of a pain the first time figuring out what your filter offsets are. Basically, you focus the camera several times with the luminance frame, and then focus it several times with the red frame, or with the red filter, take the average of the two and see, oh, how many ADUs, these aren't actually microns technically, how many ADUs do I need to move in or move out? Negative is move in, positive is move out. Once you build those out, then you can always use the luminance filter for focusing, and it will automatically correct whenever you change filters, which is really nice. All right, moving up to the top. When you run an autofocus routine, and you'll get to see it running in a minute, you got to tell it, well, how far out of focus do I need to move to start building my little hyperbola for picking my best focus point. So I've got it set pretty conservatively. It's going to move 4 steps over to the right outside of focus. And it's going to move, this is kind of trial and error to find what works with your focuser. But in my case, 60 ADUs worth of movement. It'll do that 4 of those over. So it'd start by moving 240 ADUs outside of focus and then work its way inside and go 240 ADUs inside of focus until it gets a nice curve. And you'll get to see that running in a little while. That's trial and error to find what works. For a while, I was trying to get away with just doing 3 measurement points aside from the point of best focus instead of 4. I wasn't getting quite as good results. I was trying to get a little more throughput by just having it run faster if it only had to measure 3 on either side of focus. But I found I was better off with 4. The value of 60 works really well for me, but it'll be completely different for every telescope. The autofocus method is going to be star, half-flux radius, period, the end. There is an experimental contrast detection. I think that's intended for planets and things like that. It doesn't work for deep sky. So just leave it on star, half-flux radius. Curve fitting, particularly with hocus focus, should be hyperbolic. It works every time for me, so number of attempts, 1 is fine. And then down here, the use brightest end stars. I don't tell it how many stars to pick. It just picks the number of stars it wants to. So 0 accomplishes that. Outer crop ratio. So this is how much of the frame is it going to use for a focus run. In my case, I have it download the entire frame. It needs to get an 80% fit on the to the predicted hyperbolic curve, and it will use the central half of the frame. That's what this inner crop ratio is for, to determine best focus. I don't want it trying to use stars in the corners that are never quite as good. So I have it using half the frame to pick the point of best focus. 1 exposure at each point works fine. I've never seen anyone needing more than that. Backlash compensation. So I always have the focuser start too far out, overshoot on the way out, and then it overshoots a lot. I've got it overshooting by 250 ADU. I found experimentally, I probably didn't need quite that many, but I definitely needed more than 200. You're just trying to eliminate backlash on this, and my focuser has a lot of backlash, so I've got a pretty big number here. You would find most people are running smaller numbers. This, though, is purely experimental for your hardware. I don't know any trick to, well, how do I figure out what's a good value there? Start big. It doesn't cost you much time, and then you can try and trim it down if you want to see if you can get focusing to run a little bit faster. But in general, I can get through a focusing routine in about 80 seconds, which isn't too bad. I'm not losing much imaging time for my routine autofocus. Any questions on this screen? That was a lot to go through. Okay. I will jump to dome control. Dome control, I know nothing about. I I have run a dome of my own in the past, but not with Nina. I ran it with the SJAA. So can't tell you a thing about how to get this running, but I know it's intended to accomplish the same thing as the SJAA, meaning how do I keep the slit of the dome in front of the aperture of the telescope? But I haven't had to play with any of the settings in it, so can't tell you how to make this part run. Imaging. All right. There's a bunch on this screen as well. So first thing is, what format do I want to save my files in? FITS is still more universally accepted than XISF, which is really just PIX and site specific. So I stick with FITS. There is support for a higher bit depth version of FITS, and I think this may cover single file for multiple colors as well. Some other things. I haven't played around with that. I don't need a 32-bit. It's a 16-bit camera. I don't need a 32-bit file. I don't want that hit in storage. So I just leave that turned off. You can pick your profile for where it's going to store all of your images. I just have it going into my user directory into pictures. All right, this image file pattern. This is just the naming convention for any of your files. I'm going to click that little triangle to shrink it down, so I'm just looking at one of those. So it puts double dollar signs around keywords, and the keywords are all located here. So if you wanted to start your file name with, I don't know, the type of file it is, right? I'm taking a light frame, something like that. You would start by going, where is that? It's in here somewhere. Oh, there, it'll be in this section. Image type. Is this a light, a dark, a bias? What is it? You would just drag that up and put it there, and it'd actually start by putting, oh, it's going to be a light frame. And then I put in a little underscore just to break up my file naming, and it'll show you what is it going to look like based on this. So I'm going to take that back out because I've already got that in somewhere else. But the particular naming convention I ended up with is first, show me the name of the object I'm looking at, which is target name. Then give me the date, but it's the date minus 12. The reason it's the date minus 12 hours is I'm always imaging at night. So if you do date minus 12, it won't flip over at midnight. If I want the night of the December 16th, 17th, I just want it labeled the 16th. So if you do date minus 12, then the entire night is going to be labeled the 16th, even if half of it was in the 17th. So that's what the minus 12 is for. So there's the date, then the image type, then the mode on my camera. Some cameras have multiple modes, like my QHY camera that we're hooked up to has a high gain mode, a low gain mode, a double readout mode, all kinds of different modes. You'll see those in a couple minutes. Most cameras don't have multiple modes, so you could leave that out. The exposure time, was this a 30-second image, a 60-second image, etc.? What was the gain of the telescope, of the camera? What temperature was the camera sensor at? And it, by the way, does have two separate, it has the actual sensor temperature and the temperature that you set it to. I use the actual sensor temperature. That way I'll notice if, I set a set point that wasn't realistic. Like I set it to cool to minus 20, but only got to minus 12. I might want to know that. That could be useful because I might want to get some different darks. So I have it showing the actual temperature that the sensor's running at. What filter did I image through? In this case, it's showing the little L here for luminance. And then it just gives a frame count. Frame 1, frame 2, frame 3, etc. This works well for organizing the files, finding what you want, making any, if you were doing mosaics, it would give you enough in here with the name in particular, to split it up so that it could calibrate or register frames separately. But you'll have your own convention for how do I want to name my files. It lets you name flats and darks separately. So in particular, flats and darks, I don't need a target name, right? It's just a flat or it's a dark. In the case of darks, I don't need a filter name, right? Because it doesn't matter what filter was in at the time. So you can have slightly different naming convention for different types of files. So that's that section. These down here are just the list of keywords that you can drag into your naming convention. All right, everything across the top right here. So meridian flip settings, first of all. I have mine flipping 5 minutes after it crosses the meridian. With my telescope, I know at every angle I've got an hour safely. So I don't have to be very finicky about this, but I have it going 5 minutes past meridian. The longest exposures I ever take are 10 minutes, so I tell it don't wait till more than 15 minutes after. That way it'll always be able to finish out whatever exposure it started after it crossed the meridian. Use telescope side of peer. This one is just always set that to on. That's if you ever got a mismatch because it hadn't done a meridian flip. You want to make sure that it's not thinking the telescope is on the other side of the pier because of how the mount handles that. Just leave that on unless you have a really, really good reason not to. Recenter after flip. Not that many mounts, if they were pointed at the target perfectly on one side of the meridian, are going to be still pointed at the target perfectly on the other side of the meridian. So I have it set to do a plate solve after a meridian flip. That's what this is for. After the meridian flip, I also give it a short delay to make sure that the right ascension drive has engaged fully, right? That there isn't a little bit of slop or backlash there. So 30 seconds is enough to cover that. I don't have a need to redo my autofocus after meridian flip. If I were running something with a movable primary mirror, I might need to. This is something I probably should turn on and never have. Rotate image after flip. It can be really convenient when you're blinking frames later when you're looking at your images. It's annoying sometimes that you'll be going through the images and suddenly a couple of them are upside down and then a couple are right side up, then a couple more upside down, etc. If I turned this off, it would make sure everything was oriented the same way. So I thought it'd be kind of nice for blinking. I was kind of scared to turn it on just because my hardware is pushed so hard. I don't want it to have any extra work to do. But if you're not pushing if you have a better PC than I do at your telescope, I'd probably turn that on. Annotate images, I'm not doing anything with that. Debear is turned on by default, but I'm running a monochrome camera, so that doesn't do anything. If I were running a monochrome camera, I probably would want that turned on because I would want it to be using the debared image for determining half flux radius for basic measurements. And I would want the unlinked stretch turned on. That way my previews of the images I've just taken wouldn't look green. It would get a moderately natural color balance. And then finally, this is where you tell it, oh, by the way, I'm using Hocus Focus, not Nina's default system for detecting stars, determining the measurements on stars, and running autofocus. So this is where I turned on Hocus Focus. Advanced settings is kind of buried there, but it's good to know that it's there because you probably will want to tweak this. This is basically how aggressively is it going to stretch your images so that you can evaluate them as it captures new images. So what's it's going to set as a background? How many standard deviations is it going to set the black point below that? So these two settings actually, even though they're hidden in here, normally this is closed up. You will need those. And then finally, where is it going to store? These are actually Nina defaults, but where is it going to store sequence files? Where is it going to store templates? You'll see how those work in a minute. Where is it going to store target files, etc. And if you ever, the imaging tab here, I'm going to jump to it for 1 second. If you ever make a bunch of changes in here and get yourself lost and can't figure out how to simplify it or get it back, or you want to start over because you think you've messed stuff up, the place where you do that, where was I? Sorry, was here. You can reset the layout back to factory defaults if you ever need to. I'm embarrassed to say I had to use that button on more than one occasion because I just couldn't get the imaging tab to look the way I wanted it to. This is specifically for the imaging tab, and you'll get to see more of that in a few minutes. All right, so that's the that's the imaging file settings section. Plate solving. There are only a couple things you need to do in the plate solving tab. One, hopefully you will have already installed ASTAP. This is its default location unless you overrode it. You have to tell it where ASTAP is located. And you have to tell it, yeah, I'm using ASTAP or I'm using astrometry.net or whatever you're using. I've had great luck with ASTAP. I'd recommend it. If it ever fails to solve, this is, okay, will it widen the solve and try to solve it blindly if you were just nowhere near your target? If you were off by 30 arc minutes or more, will it try to run a blind plate solve? And the answer in my case is yes. I don't think I've ever had it run it, though, aside from if the observatory closed in the middle and it tries to run a blind plate solve and there are no stars anywhere in the field, then it'll run the blind solve. So I could probably turn this off, but if your telescope doesn't point all that accurately or slew all that accurately, you might want to leave that on. When it runs plate solves, how long an exposure do you need? I've got a 2-second exposure through the luminance frame. I always bin at 2x2 for plate solves. This is the default gain from my camera's high gain mode, which is nice. How accurate when it's doing a center after it slews somewhere, how accurate do I want it to get it? What will it consider inside tolerance? I've got it for 1 arc minute. Rotation tolerance doesn't do anything for me because I don't have a field rotator. And if it ever fails to run a plate solve, how long should it wait before it tries again? Maybe because of a passing cloud or something like that. I've got it set to 5 minutes. Those are all the steps to configuring the application itself. Just running through each of those tabs. You'll just have to walk through them one time. Well, not Dome in my case, but all the rest of the tabs, you got to walk through them, take the time. Your first time through this might take you a couple hours to get it to a good starting point. That's fine. At least it's only a one-time deal. You don't have to do that, hopefully, ever again. Okay, that is options. Let me see what I wanted to cover next. Any questions on getting the basics of Nina configured? That's just so it can see the hardware. It knows how to set up your FITS files. It knows how to label your files. It knows what equipment you have in terms of the size of the microns on your camera, the focal length of your telescope, where your observatory is, etc. So that's all intended to make your image processing go well. Okay. Next, the actual hardware then. I'm going to click back on equipment here. All right, we'll run through these one at a time. So camera is the first one. If I click this little drop down, these are all the cameras that Nina is aware of attached to my system. So ZWO, I do have, the reason it shows a section for ZWO is that I have the software development kit for ZWO installed in this computer, but there aren't any ZWO cameras. So it sees a little section for ZWO, but no camera attached. QHY CCD, oh, sorry, it does. The mini camera, my guide camera, is the one camera that's attached. QHY, I've got my main imaging camera, which is this one here, QHY 600. And then there are a bunch of ASCOM cameras. There's a simulator down here which can be convenient for trying out your sequencing runs, seeing if it behaves the way you expect it to, etc. My guider in particular uses this ASI camera driver rather than the native driver, but that's in PhD, so we can skip that for now. So really, the only camera I use here is this QHY 600. So I'm going to go ahead and turn it on. So I know it's physically connected, so I'll just hit the power button here, the connect button, and it should connect the camera. Shouldn't take long. And the camera is actually the slowest thing to connect here, and it's maybe 10 seconds, something like that. And great, my camera came up. It shows that the camera's idle. It's using the native driver. It's a monochrome camera. It tells you a bunch of stuff that you probably already knew about your camera, but a few things you may not, like how big is your sensor in pixels. It's 9600. This one is 9600 pixels across by 6422 pixels in height. This is kind of cool. It'll let you know whether maybe you're getting near to needing to recharge your desiccant. Right now, the sensor chamber is running at 44% humidity. Given that it's winter, that's not too bad, frankly, so that's fine. And now that I'm connected to the camera, it'll tell me that at the moment the cooler is not running, such as 0% cooler power, and it's a little below freezing, about 30 degrees Fahrenheit in the observatory at the moment. And I could turn on the cooler if I wanted to. You can set a little ramp for how fast it'll turn on so that you don't introduce thermal shock by running the cooler really hard, or by suddenly turning it off when you go to warm the camera later. That's meant to be a flame there, so for warming the camera back up when you're done. I mentioned that my camera has a bunch of different modes. Most ASI cameras don't. Most QHY cameras seem to. Here are the different modes. I think there are 10 of them in here for my particular camera. The two I tend to use for my camera, two CMS modes are modes where it does the readout twice. So it takes the exposure once and does the readout twice. That lowers read noise a little bit because it then averages the two values together. CMS 0 is when it's running in its full high photographic mode, or high gain mode, actually. So it's as the full well capacity is somewhere around 100,000 electrons, which is really nice. And then 2CMS1 is the high gain mode, but with dual readouts. So these are the two that I tend to use. CMS1 for high gain mode for snapshots. I'll just set them both to that. And more often than not, I'm running 2CMS0 for broadband and 2CMS1 for narrowband. So high gain and normal gain. That's really what those two are. This is also where you set your default offset. USB limit, you can do a little experimentation with your cameras to see, well, where do I get the lowest amount of noise with the various values in here. 0 with my camera happens to give me the fewest artifacts in terms of slightly brighter or dimmer rows across the camera during readout. But you just have to play around with your camera to see what the best number is for you. So, and that's basically just taking exposures at 0, 10, 20, 30, 40, 50, 60, each of the key values, and literally measuring the noise levels in them. So 0 turned out to be the best for mine. So that's everything for the camera. So it's turned on now, and it seems to be running fine. And then finally down here, we get a little graphic of what temperature is it at. That's the green line here. It's just under freezing. And what's the power of the cooler at the moment? And it's not doing a thing, so it's at 0. We'll jump to the filter wheel. Oh, and by the way, one button I didn't show you, I'll show you on the filter wheel. If this is ever blank, or when you hit the drop down, if it's ever blank, you're not seeing what you expect to, this is refresh. So it'll just check and see again, okay, what's actually connected to the computer. So depending on what order you turn things on, maybe it won't see something if you turned on the device slightly before you turned on the computer or something like that. So that refresh button is occasionally useful. I'm using a QHY 7-slot filter wheel, so I would choose that, turn it on. This one's a lot simpler. It'll just show that what filter is in place right now. It's on the luminance filter. Usually when I shut down, I actually leave it on the dark filter. So I'll switch it, but you can swap filters here on the filter wheel setting. Focuser. I have an Optec focuser. It uses focus links to control it. That's the ASCOM driver. We'll turn that on. And when it's out all the way, it has a value of 65,535. When it's in all the way, it has a position of 0. Since I had custom adapters made for my camera, it actually, when it's in focus, it really is right near the middle of its range. So 32,000-ish, depending on the temperature, is about right for in focus. Temperature compensation, my focuser happens to have a temperature sensor in it, so I can tell it to, you can actually build little curves of, hey, as the temperature falls every 1 degree Celsius, you should shift the focuser by X analog to digital units. I leave that turned off for my telescope, but it's worth playing around with. In my case, I found that my primary lag, the cooling of my primary lagged the temperature at my focuser by a fair amount of time, like it could be an hour behind. So I just can't build a good temperature compensation curve. It's off. It'll be off at the beginning of the night, it'll be off at the end of the night. So I just leave that turned off and just focus more frequently than I would like to. But it's good to know that it's there if you have it. I don't have a rotator, so if I click this drop down, there isn't one. Aside from, I do have an ASCOM platform installed, so it can see some simulated ones, but I don't have a rotator, so there's nothing there. Mount. Here's where I connect to the astrophysics mount. We'll turn that on. And that's actually connecting through, I showed this briefly at the beginning, the astrophysics command center. So it uses that, which is good. And it'll show, again, the astrophysics command center knows a lot about, well, what's the site's latitude, longitude, elevation, etc. These numbers all match what we had in the configuration for NINA, since I only run it in one place. This is where the mount is pointed right now. It's actually pointed at my flat panel. So it's pointed due south in terms of azimuth, and it's actually pointed down a little bit to be pointed right at the flat panel. So when I want to take flats, this is where it sits. When I want the telescope parked, this is where I actually park it. I park it here so that it won't collect dust because I don't have a lens cap. And there's a lot of dust in New Mexico, so I want it pointed at least a little bit down so that the corrector plate doesn't get covered in dust. All right, so that's the mount connecting. Guider. I think I showed you I have PhD is already turned on. It's already connected. So all I need to do is tell it I'm using PhD 2. Good. Go ahead and connect to PhD 2. It'll find it and display whatever PhD 2 is doing. There is one other useful one in here that I'll show you briefly, which is mount dither. My mount happens to have absolute encoders, so it can do up to 5-minute exposures unguided, no problem. If I didn't want to run the guider for some reason, but I still wanted to dither occasionally, I could have it do that through the mount instead of through PhD. Then I would turn on mount dither. Most of the time, though, I just turn on PhD 2. It doesn't hurt anything. I don't really need it, but it helps maybe 1/10 of an arc second in terms of resolution for my average 5-minute exposure. Probably not so much as that for a 2-minute exposure or 3-minute exposure, but I still tend to use it. Switch. This would be for turning, if you have like a digital logger switch for turning power off and on for particular accessories. I do have one of those. I have to because it's a remote observing site, but I'm not running it through Nina because one of the things I need to be turning off and on through the switch is the computer itself, which means I don't want Nina doing it. So I have to access that from the public internet just through a browser. So I don't bother to configure the switch in Nina. Flat panel. I do have an Optec All-Natac flat panel. We can connect to that. Weather. Conveniently, Deep Sky West does provide integration to their weather monitoring system, so I can connect to it. Don't have a dome. Safety monitor, that also comes from Deep Sky West, so I can connect to that. All right, so that's everything, all the equipment turned on and configured properly. Any questions on getting the hardware running? Okay. Next is plugins. So I'm going to click on plugins here. You got two sections. You've got the ones you've already installed and the ones that you haven't. So first show what I've got installed. Advanced API, this turned out to be something that was required for, can't remember what I needed to use it for. Oh, I think this was required for the live stacking.
It's for,
I only put
touch and stars.
Oh, is that that's what it's for? That's right. Not quite the live stacking. Touch and stars. Thank you. So, so I've got it in there because I did play around with touch and stars, but I don't routinely use it. Astrophysics tools. This I do need and use heavily. This will let me build pointing models for the mount within Nina without having to do that in astrophysics in their own tool set. Super convenient. There's an equivalent for 10 micron if you're running a 10 micron mount. Connector, all the things that I turned on a minute ago, the camera, the filter wheel, etc. Connector can turn them on for you automatically when you launch Nina, which is nice. Discord alert if you wanted to let yourself know about error messages throughout the night. It could send a message to a Discord server. Hocus Focus, again, this is the one that please, please, please do install first thing. Highly recommended. Not quite indispensable, but awfully close. I haven't played around with the Lucky Imaging yet, but I intend to, so I installed it. Remote copy can be used to move your images in real time from whatever your computer is at your observing site onto, in my case, I've got a storage area or a network attached storage device, so we can do that via remote copy. SGP server emulator turned out to be a prerequisite for, I think, getting SPCs, the astrophysics tools running. So I ended up installing that, found that in the documentation. It's not something I use actively, but it was a prereq for, I think, the astrophysics mount. Speckle interferometry, again, I thought it'd be something fun to play with, but I haven't yet. And the last one that if we have time, we'll get to at the, well, we probably won't, but Target Scheduler is really cool and something I recommend you play around with once you're comfortable with Nina. First, get comfortable with Nina, make sure you can get it running, doing what you want it to, etc. But once it's doing what you want, the Target Scheduler will let you do things like, hey, I know I want to image these 12 galaxies this spring. Please figure out the best order for imaging them throughout the night so that I get 3 hours on this one, 2 hours on the next one. Maybe I wait till next month for the third one, etc. It will figure all that out for you and let you put the objects in, and it'll pick the priorities based on weightings that you provide. It will run the exposures you want. It'll do, it's really cool. But it's not, you want to be comfortable in Nina before you move to that. But once you're comfortable in Nina, it's awesome for optimizing your throughput. If you really want every hour of every clear night that the moon isn't in the way to be utilized, there's nothing better than the target scheduler. And then we'll look at what other plugins are available. There are a ton out here. Scroll through, take a look, see if there are things that you're interested in. New ones appear all the time. I won't try to take you through any of them now, but things like, maybe you're using a batten-off mask. This can make it much easier to use a batten-off mask. It'll tell you exactly how much you're off by. You probably wouldn't do that if you were remote imaging, but if you were imaging in your backyard, that could be really convenient as an example. There's a target planner for figuring out, okay, well, which 6 galaxies do I want to image this spring? It can help you with that sort of thing. So a ton of additional plugins there. So just read through the list. They do have descriptions of what they're for and how they work. All right. Next thing I wanted to jump to. Okay. This screen. This is where, if you're watching Nina doing its thing, this is where you're going to be. This is the imaging tab or imaging screen. I find this incredibly busy. There's this box here is where it's going to show the actual image. That isn't a lot of screen real estate. I'd like to have a lot more. A bunch of this stuff I don't care about. Some of this stuff I do, but I don't like the way it's organized. You can tweak this to your heart's content. Anything you want to do in here, practically you can do. So for example, I don't need to see information on my mount status. I don't care. I mean, if it's taking pictures, my mount's clearly working. I'm happy to get rid of that, so I'll just close it. The weather integration, I don't need to see that. I'll just close that. That gives me a fair amount of empty space here on the left side. And I've got a camera and a focuser. Well, I'd like to see both at the same time. So how about if I decide to have separate little windows for each? I can just grab the focuser tab here, drag it up, and tell it by letting go right here, put it just below the camera. And it'll fit it in and it'll keep it there live. Filter wheel, I do like seeing the filter wheel. Guider down here. Guider takes, this is my PhD 2 information. I'd rather see that in PhD 2 where I can actually do something about it. So I tend to get rid of that. The radius, the history of my half flux radius, I don't care about. I'll get rid of that. Statistics, I do like to see the statistics on my images, but it's getting its own column. That's a huge waste of real estate as far as I'm concerned. I'd rather have it down here instead of the image history. So I'm going to get rid of image history. I'm going to grab this, drag it over, hover over the sequence section, and hover over this little down arrow here, and it'll drop it below sequence. So I can never remember how to do any of that stuff if I haven't done it recently. So I end up screwing this up all the time. I practice it like 3 times this afternoon, which is why I was able to do it for you just now live. But you may find yourself resorting to that thing I showed you earlier of back under options, under imaging, reset the layout if you screwed up and you can't find stuff. But this is essentially the layout I like. It gives me a lot more room for the image so I can see what the heck is going on. And I'm only seeing the tools that I actually care about while I'm imaging. Even a couple of things down here, the star annotation options. This is part of Hocus Focus. I don't need that. So I would tend to drag it somewhere and then Oops. Turn it off. Because that's something I would set one time. I don't set it all the time. Same for star detection options. Just drag it over here somewhere so I can move it and then turn it off. The rest of this stuff, yeah, I might use all of that. Maybe I want to see, I told you that if you're not seeing something that you want, often these little buttons across the top have it. Like I want to see my last autofocus routine. I want to see what it looked like. So I'm going to turn that on. Oops. Yeah, turn that on. And I want it as one of the little tabs here. So I'm going to put it, I drag my mouse to this little button. Is that right? Nope, that wasn't right. Let's try that again. Yeah, this UI is a pain in the neck, but once you get it right, you never have to touch it. And oops, let's turn it on. And do I drag it to, where do I drag it to? Just there. And it'll create a little tab for me if I put it right on that toolbar. So now I've got things that I might actually use. Image, star detection result, aberration inspection. This is for identifying tilt in your system. Target scheduler. Again, that's the more advanced way to schedule your observing run for the night. And autofocus, I can see my last autofocus run. So cool, those are the things I might care about. That works. Once you get it right, save it, because you're gonna mess it up at some point. So again, back in options, the same place where you had that reset button, you also have the ability to back up, save a copy of your layout. So once you know, yep, this I like, I'm comfortable with this, save it so that you can restore it at any time. Okay, so this is me. You're going to have your own preferences. Set it up however you like it. If you don't need so much real estate devoted to seeing the image, cool, no worries. I think that's everything aside from, great, how do we actually use it, right? So the sequencer, well, actually, we're going to start in framing. And in the interest of time, we're going to try and actually take an image or something bizarre like that. So let's assume when I click on framing here, let's assume I want to look at M33. It should be pretty high right now. Triangulum Galaxy. So I'll type in M33 in the name here. Select it. Great. It shows the right ascension and declination. I've got it show 2.5 degree field of view right now, which should give me, with my particular camera, a fair amount of wiggle room to see the area around my frame. But this will be, whatever's appropriate for your particular telescope. If you were running a wider field telescope, you might need 3 degrees or 3.5 or something. If you were running a plane wave 17-inch, a degree might be ample. And then I didn't tell you, but I clicked on load image. Right now it's loading the image, or it just did load the image from the NASA Sky Survey. Other things will load faster. I use the NASA Sky Survey because it's an actual image in the background there. Let me drop the opacity so you can see a little better. It shows me the framing for M33 with a real image, so I can figure out, is this really the composition I like? And if I don't like it, if I want to tweak it a little bit, I don't know, put it in the top right corner of the frame for some reason, or center it a little better, I just drag my frame around until I've got it where I want it. I'll raise the opacity a little so you can see what I'm doing better. Maybe something like that. And it updates the right ascension and declination in real time, which is cool. All right, so now I know this is what I want to observe. How do I set up my sequencing run on it? How do I tell it, great, I know what I want to observe. What does it need to do? You do that with the sequencer. So this is the heart of Nina. This is where most of the headaches are, aside from the initial configuration. This is where most of the power is. It's divided into 3 areas: the sequence start area, the target area, and the sequence end area. Think of it as the sequence start area is, okay, how do I unpark my mount? How do I cool my camera? How do I get everything ready to go, waiting for the target to appear, waiting for nightfall, waiting for whatever it is it's going to be waiting for? So you can drop instructions in there for getting your telescope running. Um, it's a real pain in the neck to build these sequences manually. They can get quite complex. I'll show you an example. I'll just load one from a couple months ago. This one happens to be a 6-panel mosaic, I think, or something like that. Yeah, 6-panel mosaic. There are a lot of instructions in here. You don't want to have to build those from scratch each time. So you're not going to. So let me show you what you do. The easiest thing to do is use templates. So up here, these are the different instructions you can drop in. Here are the templates. Nina comes with 3 basic templates. Ignore those. Instead, find a set of templates published by a website called Patriot Astro. I forget the gentleman's name who put them out. These are a great starting point. Lots of people use them. Lots of people are familiar with them. They may not be exactly what you want, but they're going to be comprehensive. So he's got a few in here. He's got a basic start of the sequence, and he's got a basic end of the sequence. There isn't a lot in there. There isn't a lot to getting the system running. There isn't a lot to turning it off, right? Turning it off is basically parking it and warming up the camera. But he's got a good starting point, and he has a lot of notes to explain what you might want to do. And then he has templates for mono imaging in LRGB, mono imaging in LRGB, but with focuser offsets. Maybe you have a field rotator as well. He's got a template for that. Maybe you don't have focuser offsets, but you have a rotator. What about narrowband, etc.? A one-shot color camera. One of these is going to be a good match for your system. It's a great starting point. In the interest of time, I'm going to use one of mine instead, because it's specific to my hardware and we won't have to modify it so much. So first I'm going to put in the startup. I'll put that there. And then I'm going to show you the actual target scheduler, but we're going to delete it in a moment. But I'll at least show it to you first. So let's start with these two. So to start my system up, the first thing I do is I wait for a time. What time do I wait for? I wait till it's dark, but I actually start an hour before it's fully dark. So it's wait for astronomical dusk is full dark, but back up 1 hour. So 1 hour before dark, I unpark my telescope. That's the unpark command. And I slew to point it not quite straight up, and then I stop it. So no sidereal tracking. Why do I do that? My telescope benefits a lot from cooling, and cooling pointing up. Other telescopes may not, but that works really well for mine. So I do that an hour before dark. I slew it up and just have it sit there, and it cools off very nicely. Then I have it wait for 40 minutes. Because again, it was an hour before dark. Now, once this time span has passed, it will be 20 minutes before full dark. That's a great time to cool the camera. So I tell it to cool the camera. It's winter, so I can cool it to -20 and take 5 minutes or so to cool it to -20. And then wait for full dark. So that's my full startup routine to get everything ready, is to run those instructions. Then, how does it actually image? Oh, I didn't use the one I meant to. Sorry, I'm going to delete this one. How does it actually image? I want this one. Red, green, blue. Drag it over. So everything is in little wrappers. So first is what Nina calls, I'm going to click on the instructions so you can see it, what it calls a deep sky object wrapper, her instruction set. So that's this one. My target is going to be something that I already know I want it to be N33, but I don't have the coordinates in here yet. So this is just a wrapper for it. So for M33 that's going to be at some right ascension and declination and some field rotation, there are a few things I wanted to do. It's organized these. I'm going to drag an empty one in here to make it easier for you to see. So there's an empty wrapper. It's organized these into triggers, loop conditions, and instructions. So triggers are things it's always monitoring for, like, is it time for a meridian flip? Is it time to refocus the camera? Is it time for stuff is what you put in triggers, something it needs to monitor all the time. You can add them in manually. Here are the different things it can do for a trigger. Maybe it checks every image to see whether it's still pointed where it's supposed to be, and if it's drifted by more than some amount, it'll recenter it. So things like that. Those are things you put in the triggers. Loop conditions. You might tell it, I want to take a bunch of red, green, blue images. How many times should it loop through taking those images? So you might tell it, well, I'm going to loop until the moon comes up, or I'm going to loop until the sun comes up, or I'm going to loop until a specific time. So just keep doing stuff until something. Or I'm going to loop until the moon illumination hits a certain percentage. Whatever it is, this is how long are you going to keep going? And then the instructions are, what are the things you're actually going to do? All right, so let me get rid of this empty one again, and we'll go back to the one I populated. So for mine, I don't have anything in triggers. I don't have anything in loop conditions because, whoops, I'm still in startup. Scroll down. So I do have things in triggers. Sorry. Meridian flip. I always wanted to be looking, do I need to do a meridian flip? I always want it checking after, in this case, each one image, have I drifted by more than an arc minute? If I've drifted by more than an arc minute, it's going to center. My mount doesn't often drift by more than an arc minute, but if I get too many dithers in the same direction, maybe it might. Those are the two things it's always looking for in the triggers. Then I've got my set of instructions. Within my set of instructions, I embedded instruction sets. So I've got two sequential instruction sets. Sequential just means it's literally going to go through them one at a time. Parallel would be things that it could do at the same time, like maybe warm up the camera and park the mount. So I've got two sequential instruction sets here. The first one is wait till I'm ready to image the target. So it might be set the camera to mode 8, which is my dual readout low gain. Wait till the target is above 30 degrees. If the moon is out, wait till it sets. Once all those things have happened, the target's high enough and the moon isn't in the way, start tracking, run my autofocus, and slew to the target, and then start guiding. So this is great. I hit the point where it's time for it to start imaging. This is everything I want it to do. Next is the actual imaging itself. So in the case of mine, my telescope needs an awful lot of refocusing. I need to refocus my telescope every time the temperature changes by more than 3/4 of a degree Celsius. And just as a safety net, because the primary mirror lags the actual falling temperatures throughout the night, I have it running every half hour. So whichever of these hits first, it's going to trigger a refocus. And then what are my loop conditions? It's going to keep going until either dawn comes, or my object sets, or the moon comes up. Any of those three things, it'll be done for the night. And then it's going to take images with my red filter, my green filter, and my blue filter. So I don't expect you to remember all of these things, but if you go find Patriot Astro's templates, they'll be all set up for you. Mine are specific to my telescope. This is what we're going to use for tonight. But do start with the Patriot Astro ones. You can even find lots of people who've on Cloudy Nights or whatever who've used the Patriot Astro ones, liked them, told you about the problems, told you about the gotchas, whatever. So you'll be able to find support online for them. And they're solid. They're good. They're a great starting place. Okay, so this is my sequence. It's ready to go aside from the fact that M33 isn't in there and I didn't tell it how to shut down. So I'm going to grab my shutdown one and put it in my shutdown area here. What does it need to do to shut down? Well, all it needs to do is warm up the camera, park the telescope, go back to my default read mode, put my dark filter in, and then I know as my telescope cools throughout the night, typically on an average night, it will move to about 100 counts inward. I want to put it back at the starting point. So I move it back out 100 counts so that my first autofocus of the night goes better the next night. So that's everything to get it running, aside from, I haven't told it that I want to do M33. So how do we do that? All we do, we'll go back to the framing. This is where you may remember I set up the exact framing I wanted of M33. We'll do that. I like that. Now all I do is I add the target to the sequence. I click on this button, and I'm going to tell it to use JSW RGB instructions. And it'll fill it all in for me. So now the target actually has the right target. It has the right ascension declination. My camera happens to be in there at an angle of 89 degrees. I was trying for 90. It wasn't perfectly straight, but it was pretty close. 89 is pretty good. And I don't have a field rotator, so that's where it always is. This is ready to go. Everything I need is all set up for a night of imaging M33. I'm going to make one tweak to this for tonight, just to make this easier for us. Instead of imaging red, green, and blue, I'll get rid of the red, the green, and I'm going to tell it to just take some luminance frames. So now it should just start doing 2-minute luminance frames over and over and over again until M33 gets too low. And it thinks that would happen. Well, dawn would come at 5 a.m. or a little before. It's going to drop below a little after midnight New Mexico time, or just before 1 a.m. New Mexico time. It'll drop too low and it'll stop. This will be the one that actually causes it to exit, right? So this sequence would run till a little before 1 a.m., assuming no clouds or problems like that. So I think we're good to go. So let's try it out and see if it works. I'm going to pull a couple of these things that we know don't apply just because it's not the beginning of the night now. It doesn't need to wait to begin with. It will need to unpark the telescope. It will need to slew somewhere. We'll just have it wait 10 seconds. I don't want to wait 40 minutes. I'm going to turn the camera cooling on now just so we don't have to wait for that. So I'm going to go into the camera control and literally just tell it to start cooling. Let's go back to the sequence here. So we'll pull that one out. We don't need it. We don't need to wait for full dark because it's already dark in New Mexico. That should work. So this should get it going. All right, I've got two places I can launch it. The first place I can launch it is with this play button down here. The second place I can launch it is in the imaging tab. I can press, this is the little sequence window, I can press play here. They're identical, it doesn't matter which we use. I'll do it from the sequencer. So we'll hit play and we'll see what it does and see if we get an image. So it unparks the telescope. Oops. Now it's busy slewing. You can actually watch it slewing in the astrophysics software. We should see a little red dot appear here in a second. There it is. That little red dot is as it's slewing around to the east side of the mount. I actually should have told it west side since this object has already crossed the meridian, but too late for that. So we'll give it a minute. I've got because it's winter, I have my mount slew speed set pretty low, just because the grease gets a little thick and I don't want the motors working too hard. So it's only going at 600x sidereal rate, so it takes a minute. But it won't be too long. Any questions while that's slewing? Okay, it's on the west side of the mount now. This again isn't Nina specific. This is for my mount in particular. So unless you're running an astrophysics mount, you won't see this box. I'll minimize that. And it's still running. We can see the little progress icon there. Good. Now it's waiting 10 seconds, which I didn't need to do, but I left that in there. It's short. All right, it's done waiting the 10 seconds. Oh, hold on. I took one too many things out. The autofocus is going to fail. So let me stop this real fast. I think. No, okay, it won't. I got it right. All right, so here's the autofocus tab. We'll see whether it manages to find focus. So it's starting at, this is arc seconds, so it's starting at 3 arc seconds for half flux radius for the first point it measured, and then 2.7-ish, 2.6-ish arc seconds for the second. We should get a nice little hyperbola out of this. This is Hocus Focus doing its magic. So that's the 4 points that are to the right of focus. The next one, in theory, should be about in focus. So it should start to level out. It's beginning to. And then we should get 4 more points on the other side as it works its way up the curve on the other side. And it didn't quite get to bottom yet. Great, so it's past the bottom. And it will start going up. And you'll also get to see one of the cool features about Hocus Focus here in a moment, which is the fact that the two sides of the hyperbola in my telescope are never quite identical, which is common for telescopes with large central obstructions. And Hocus Focus can account for the fact that, in my case, the side inside focus is a little bit steeper than the side outside focus. So it'll actually get me a better center point than the default focusing routine. Should do one more. Maybe that's it. Nope, that's it. Okay, so in running that focus routine, well, I'll show you those numbers in a moment. Now it's slewing to M33, and then it'll run a plate solve on it. And let's watch it slew real fast. All right, so it's doing a meridian flip because I did my focusing on the east side of the mount. Now it's moving to the west side of the mount for M33. Almost there. All right, it's settling after the slew. Now it'll do the plate solve. So 2-second exposure. And it's off by a lot. M33 is all the way up here. It's decided it's off by, wow, an entire degree. or excuse me, half a degree, 36 arc minutes. There, it centered it. It's now off by 3 arc seconds. So cool. It just turned on the guider. So let's take a look at PhD. Should be guiding now. It is. It says it's guiding down here. So good. And it's gotten to the point where it is now exposing. So we should have an image in 2 minutes. So while we're going back to the imaging tab here, it now has the focus image, or the last plate solve image shows here. So that's a 2-second frame stretch so that we can see it. We can see the progress of the sequence here. So we know it's on its first of 6 images before it would then loop and start all over again. If I want to see what my last autofocus run looked like, I'll click on this little autofocus tab and I can see before it started the run. Oh no, it doesn't show it here. Sorry, I should have told it to save the run. As it goes throughout the night, it will show here the where the half flux radius was when it started, where it is now, and what the different points were, so you can just monitor how it's doing. But we'll wait for it to finish at least one image here, so 1 more minute. The only other topic, while we're waiting for this, the only other topic I wanted to cover tonight was how do you get support for Nina? Nina, because it's open source freeware, is supported just via Discord. So you have to create a Discord account, ask questions there. There are no official tickets. The user community is there just as the development team is there. They're super responsive. I have never had trouble getting support for Nina. Dale Gent, one of the developers, actually sat on the phone with me for about 3 hours one night when I had trouble with my filter wheel, and it turned out to be a hardware issue. They're amazingly responsive, but there's no ticketing system aside from the Discord channel. So just one thing to be aware of. And here we've got our first image. So there's 1 luminance frame of M33. Half flux radius is 2.5 pixels. That would work out to be about 2.3 arc seconds. Typically for mine, when I measure the full width half max later in PixInsight. So decent seeing. If we zoom in on it, stars look nice and round. And that was a corner of the frame. Let's look at the middle of the frame. Yeah, focus looks good. Everything looks good. So that's it. It's doing exactly what it should. If we want to see where it stored the image, I'll just bring up File Explorer here. Click on Pictures. I took a couple test shots before we joined this evening. So these were just before 7 o'clock Mountain Time. This is the image we just took a moment ago. So it's storing the images, doing exactly what it should. Everything looks great. And I would now go to bed and check it in the morning. So I know that's a ton of stuff, but you'll have access to the recording, so you can replay anything that you need to. It should at least give you enough of an orientation to where you can get going and start playing around with it. And as with any software package, by far the best way to learn it is to just try and use it. But now that you've seen it running in action, that shouldn't be too painful. Any questions?
All right. Well, thank you very much, Jared. Yeah, that was terrific. So please, I know it's late, but we have time for a few questions. So if anybody has any, now's the time to speak up.
I have a question that is more than about the Nina, is about the setup that you described, Jared. You were saying
Sure.
that your telescope has a kind of thermal inertia, and so you cannot use you cannot use the automatic compensation for temperature in the focuser, right?
Yeah, what I could do that I haven't bothered to do is put another temperature probe on the primary mirror instead of just using the one in the focuser.
Oh, right.
So if I bothered to do that, then I could use the temperature compensation. I just need to be measuring it at the right spot, and I'm not. The only place where I've got a thermal probe right now is in the focuser,
Yeah,
and that's
and
not
I have
helpful.
I also have a focusing system that has a temperature sensor, and my temperature sensor is next to the lens cell. But my problem is that the focus controller does not know when an image is being taken and when it's not. So it would start uh, refocusing during the image taking. And so I had heavily lobbied the Lina developers to introduce this instruction, move focuser by temperature in a
Right.
relative mode. That does exactly what I want. I can put it in the sequencer just before taking an exposure, and that's it.
Yep. Yep. I've for right now, I've just given up on that. Longer term, I may well. Did they actually introduce that?
Yes.
Or they did. Okay, good. Then
The
yeah, I could add a probe to mine, put it on the primary, and take advantage of that. Yeah, you don't want. Even good focusers tend to have a little bit of focus shift, so you don't want it making the adjustments in the middle of the image, right?
exactly.
So absolutely, that's yeah,
The
you're
only
right. It
limitation
needs
that
to be
I've
a
seen
separate
is that
instruction.
it assumes that the relationship between the focuser position and temperature is linear,
Yeah.
which is a reasonable assumption for a refractor. I don't know how it is for a more complex system like you have, but yeah.
If I were measuring at the primary, that would be, let me put it this way, it would be a lot better than having to refocus every 30 minutes,
Yes, of course.
right? Because I lose about 10% of my throughput to focusing runs.
Yeah,
And I
improved
would love
efficiency.
to bring that down a little bit. I only run about 85% efficiency of, how many of the minutes in the night that I could be imaging, what percentage am I actually capturing photons? It's about 85%. I'd really like to push that up towards 90.
Wow. And I agree with you that one of the greatest assets of Nina is the community that the developers
Yeah.
of the program, but also the developers of all the plugins that are all available. Most of them are available on Discord.
Yep.
And the number of plugins is now, I don't know, was it like 50?
50, 60. Yeah, it's a bunch.
Yeah.
And I mean, it covers a lot of it. They're niche things, but if you care about that niche thing, it's absolutely indispensable,
Yeah,
right? If
exactly.
you want to do lucky imaging, this is a really cool way to get going on lucky imaging. I just haven't tried it yet, right? But the fact that you can define the region of interest, that you can run it as a video file or as still images. I mean, it's cool stuff.
Yep.
And most platforms don't support those niche requirements. So the fact that they allowed third-party development was smart. A lot of people are too short-sighted about that. I think that's one of the areas where software BISC went wrong
Yeah,
years ago.
it's actually a good architecture. I wrote for my personal use a plugin that consumes the meridian description from APCC. And essentially, instead of having a fixed time for a meridian flip like Nina provides, it will have a different one by declination.
Oh, cool.
Yeah, it's not difficult. There's basically a wizard that lets you create the skeleton for the plugin, and then you have to add your logic, of course. And you can customize a lot of things. You can spans the gamut from device driver to UI enhancement.
Mm-hmm.
All right. Are there more questions? Well, let me follow up with one question about plugins. So how do you, know to trust a plugin?
You try it.
No,
I don't know of a way to know without trying it and seeing if
no, I
it's
mean,
not going to break anything.
well,
Are
that's
you
the
talking
question.
about security?
I'm talking about security. Well, you're a security researcher, aren't you? That's your field. So how would I know that somebody's not, trying to hack my computer by making I mean, it sounds like a great idea. Don't get me wrong. That's what I would worry about. So what's the answer?
The answer is that actually I don't believe that there's any verification
Yeah,
process.
I don't think they do a thing. The major thing that I would consider the protection is the vast majority of us are running these on computers that, well, they're technically connected to the internet, but they don't have any personal information. They're just for imaging.
Yeah.
For most of us anyway, right? I mean, this is a little mini headless computer at the observatory. If they wiped the entire drive, it would not be a disaster,
Hmm.
right?
And there's
So
actually, I think that the answer to your question, Hai, is actually twofold. If you're talking about is there malicious code in this plugin? Yes, there's no verification for that. If you're talking about is the source of my plugin the one that I expect? Yes, because there is a server maintained
yeah,
by Steven, the main developer,
Steven Berg, yeah.
that has basically the metadata for all the plugins that exist, and from that is the source of truth for the trusted URL from where to download the file.
So I didn't follow you, but you're saying that he looks it over, the source?
He maintains the metadata file for everybody, so you cannot get Nina to download a plugin from a different source.
Oh, okay.
You can install it manually if you want.
Okay.
But in terms of verification of the code, there's no such thing as the Apple has for the application in the App Store. There's no verification.
Yeah, that's probably work, right? I mean, it's difficult. So, can you get AI to write you your own plugin?
I did not try,
Sure.
but
You think?
I bet you could.
I bet you could. I bet you could. All right. Are there other questions? I guess it's about 2 hours, so almost. So
I have a quick question on
go ahead.
plugins also.
We'll end with you. Go ahead. Fire.
How come there's no plugin, or is there one, which will just give you the planet's position? I realize this may be kicked out of the Deep Sky Imager Society, but it would be handy just to get it to point at a planet if you wanted to look there.
there is actually.
Or is there one?
Is there one?
It's
I mean,
orbitals.
yeah, I haven't played around with orbitals. I haven't done any. My focal length is too short for planetary imaging, so I've done, yeah, this one.
Well, probably Stellarium. I assume you can connect Stellarium, right? Or
You can connect Stellarium, right? You can find stuff. It probably even has planets in the Sky Atlas, though I haven't checked.
yeah, I mean, for sure, Stellarium will give you that.
I think so.
No, it doesn't. Okay.
That's why he developed
yeah,
orbitals for that.
Yeah. So it looks like
Orbitals,
yeah, it's
cool.
already kicking off another
Okay,
autofocus
try.
run. So orbitals. Let me jump
you.
over to that and see
Thanks
what it
for a great
says.
talk, by the way.
Oh, absolutely. Absolutely. Yeah, tracking planets, sun, moon, comets, asteroids, etc. My guess is it was aimed more at comets and asteroids, but cool.
Yeah, it's great for comets. I used it for Comet Lemon in November, and it not only has the orbital elements, but can either tell your mount to track at a different speed and correct it over time, so that the mount remains the comet remains centered if you want. And if your mount does not have that capability, it can use the comet track in a feature of PHD2 to achieve a similar result.
Okay. Well, there you go, Rich. Okay. Alrighty. Well, it's almost 9:30. I guess it's time. So everybody, please unmute and give Jared a hand for that. Was a great talk, and I really appreciate it.
Thank you.
Thank you. Thank you.
Thank you.
Jared.
Thanks, Hi. And anyone who has any questions or anything they want to follow up on, my email was at the beginning of the presentation, so feel free to reach out to me. I'd be happy to answer questions or even
Yeah, do you want
walk you through stuff.
do you want me to mail the slides you gave?
Yes,
I'll mail
please.
that to the mailing list. So folks,
Yes, please. In particular, I would like anyone who hasn't optimized Hocus Focus. If you're playing around with Nina and you have not optimized Hocus Focus, there's a link in there that I highly recommend you watch from the imaging channel. They interviewed the developer and he went through great, how do you actually get it to yield good results, and it improved my full width half max by 2 arc seconds just watching that one, excuse me, 0.2 arc seconds by just watching that one presentation.
all right. So thank you very much, Jared. We really appreciate it.
Thank you,
Thank
Jared.
you.
Next time.
Thanks.
Thank you.
Bye-bye.